Hi friends, in this video we are going to focus on continuous testing. We are going to see how the CITS automated tests are configured to run in CICD.
The first important step towards continuous integration, continuous testing is to understand the version control system of this tool. Now, all our project files are stored either as a CSV or are stored as XMLs. In order to understand this, let's look at all these project files in details. So this is my test case. So if I open up this test case using this editor icon on top, it will open up a CSV file for me. Well, it actually opens up an Excel, but the file is a CSV file, get.csv. If I open up a test data sheet, let's say this purchase data sheet, if I open it up using the same editor icon, it also opens up an a CSV file, purchase.csv. The object repository is also an XML file. Let's go to the backend location of the tool. And if I step inside projects, step into my first project, and I look at the object repository, right click, open or edit with Notepad++, change the language to XML. You see, everything is stored as an XML tag. So all the objects are, or the complete object repository is an XML file. What does this prove? This proves that all the test files or all the files that contribute towards execution, or rather design or execution of this test cases, are flat files. In other words, they are all version controllable files. So which are the files that we need to push to Git? And you can configure this tool with any version control system, GitHub, GitLabs, Azure repositories, any version control system. So which are the files which will go into Git? This is the entire list of files and folders that get unzipped when you unzip the Git's setup file. Now I have created a git ignore file. If I open this up, let me minimize this. I've created the list of files that are not required to be pushed into your version control system. This will give us an indication, no matter on your local machine, whatever is the content, other than these files, every other file should go into your Git or into your version control system. It comes with the license file. The license file is practically not required. The extensions folder, this is not required. The grid node and Jenkins, the grid node and Jenkins folders are not required. In fact, so much so that you can even delete this. These are actually responsible for setting up Selenium grid on your local machine. You don't need it. And this is for easy configuration to Jenkins. You don't need it. We would see how we can set it up in a normal CICD tool later on in the second part of this video. But you can even get rid of these folders directly even from your local machine. If you don't want to delete them, it's still fine. Just put it in your git ignore, and that's also okay. The logs folder, not required. This stores all the logs, all the actions that you're performing, like renaming of objects, renaming of data sheets. Anything that you do are stored in this logs folder. And also whatever action is performed by the tool in itself is also stored in this logs folder. Then I have said that the projects and then the results of these projects do not need to go to Git. That means all the HTML files, all the images, all the screenshots that the tool captures invariably makes the Git branches very heavy. So they do not need to be pushed to Git. The web folder is not required to be pushed. The recent.items, this file is not required to be pushed. Log.txt, this is also somewhat similar to the logs that I just explained. It captures all the immediate logging that is happening uh, by you on the tool and by the tool itself. The tools folder is not required to be pushed. And the installation.md, it's just a markdown file. You may push it, you may instruct your fellow colleagues to use it to understand how to do the installation, but I would personally prefer not to push it. Instead, I would recommend a README file, a readme.md, a markdown file to be created on the root location of this repository. In that README, you write down all the best practices or all the specific instructions that are applicable for your project. That is very, very handy. We will do something similar towards the end of this project, and I will also share with you the GitHub link where I'm going to push this. So with this, we understand which are the files that should go into the version control system. What I have done is I've created a remote GitHub location, a remote GitHub repository, and a branch. I will push the contents of this folder onto that branch. So I'm going to right click, open Git Bash. You see it is already connected to the main branch, which is the remote branch in GitHub. And I will simply say git add space dot. That means it will add everything. I just recently pushed it, so it's not going to add anything new. So git add, git commit. I'm going to say -m with a message like my demo commit. As I was saying, there's practically nothing to commit because I recently pushed it to GitHub, and the next command would be git push. So everything is up to date. Now, if I go to this remote location, this is the GitHub repository that I was talking about, and this is where I have pushed all the contents. And I'm going to share the location of this GitHub repository in the description section. So now that the project files and the test files are already in GitHub, we will see how we can run this via GitHub Actions as part of CICD. Now that the test automation scripts, the files are in the version control system, in this case it is GitHub, we can easily integrate it into any CI/CD tool, like for example Azure DevOps, the Azure DevOps pipelines. We can have GitLab CI, we can have GitHub Actions, and even some of the tools like Jenkins and Bamboo are also very easily integratable. I had created a Medium article where I had explained how to integrate kits with Azure DevOps. If we go to Google simply and type kits Azure DevOps, the very first link that we get is how to integrate kits with Azure DevOps pipeline, build pipeline. So this article clearly describes how we can create a YAML pipeline. Now, YAML pipeline is nothing but a pipeline as a code concept, where we have seen what are the instructions that need to be given or passed to the YAML file in order for the execution to happen via Azure DevOps. So this is the YAML that I had used in the execution, and the GitHub link is also given, so you can check it out at any point in time. But in this video, since I had already covered Azure DevOps, we are going to run the project that we have created via GitHub Actions. That's another CI/CD tool that we can leverage. Now, I'd also created a Medium article on continuous testing with GitHub Actions. Let me go to that article. GitHub Actions. Here you go. Continuous testing with GitHub Actions. The reason why I came to this article is here we have a ready-made GitHub Actions YAML file that we can leverage for a quick start, and then we can keep on building on top of it. Okay, you can also check out this article. I'm going to provide the links of both these Medium articles in the description. So what it says is in the repository, we have to go to the actions section, and then we can create, the GitHub Actions or the YAML file that we need. But I think we can skip this step, and we can directly copy the YAML from here. So I had used this YAML to run some Cypress tests that I had created, which was a Node.js execution, but this is built in Java, so we are going to use the Java version of this YAML. So what we have to do is we have to create a .github folder, and inside that folder we have to create a workflows folder, and inside that folder we would have to place this YAML. That's all that we need to do. So we go to the root location of kits, where kits is installed, and this is where we have the projects. Inside the projects we have the project that we have created, which contains all our test scripts. So new and a folder .github, and in the .github folder we are going to create a new folder called workflows. Inside the workflows folder, we will create the YAML file, which will be responsible for creating the pipeline. So if I create a new file, I'm going to name it execution.yaml. So YAML, YML, anything is fine. GitHub understands it. So that's what we need to do. So now what I will do is I will just simply copy the contents of this YAML file, and I'm going to modify it in the editor. So this is the file that we just created. I'm going to use Visual Studio Code to edit this file. It's easier that way. Open the file, .github, workflows, execution.yaml, and it's an empty YAML that has opened up, and I've already copied the contents. I'm going to paste it. I'm going to give it a proper name like continuous testing with kits. So it says on, as in what is the trigger of this pipeline. The pipeline will be triggered whenever there is a push to the main branch, and whenever there is a pull request that happens on the main branch. So this on section explains when will the pipeline be triggered. Then we create a job, and inside a job we create a build. Now I have explained all these details in the Medium article, so I'm not going to go too much in depth with all of these actions. So runs on is essentially the agent or a server that GitHub spins up for us. I have chosen an Ubuntu latest, so a Linux server, so you can also go for a Windows agent, but it's always better to choose Ubuntu latest because it's much faster as compared to the performance of Windows. And then what are the steps that are going to be performed? So first, it says uses actions and then checkout. That means it's going to check out the code that is there in your GitHub. So it's going to check out this entire location into the workspace, and once it does that, then it starts to use Node.js. Now we are not going to use Node.js. We are going to use Java. So I would say setup Java 11. That's the action that I want to perform because I'm not sure what would be the version of the Java that is already installed in that agent. So I'm going to set up Java 11. Oh, before that, the version of this checkout has changed. So this action is now going to use, I think the latest version is checkout version 3 and not version 2 because I wrote that article last year. So the version has upgraded. So I'm going to set up Java 11. Now, in order to set up Java 11, the exact syntax and the distributions that are required can easily be found if we simply search GitHub Actions setup Java. So the first link takes us to the GitHub Actions to set up Java. If we keep scrolling down, so this is what we need to use. Uses setup Java at the rate version 3, distribution, Temirin, and Java version 17. I think we can use the Temirin distribution and set up Java version 11. That is also perfectly okay. So just copy that and paste it here. We need to, I think this is fine. And the Java version is 11. Yeah, so this will set up Java 11. Now we need, this one says install dependencies and install npm. We don't need it. But what we do need is once this entire location is checked out, we would need to assign the right permissions for this location for the control to trigger this run.command file. Okay, so I'm going to say set up permissions, and I'm going to give it 755. So chmod -r 755, and I'm going to do that to the entire directory. I'm going to give full read-write access to the entire directory. You can also find an explanation of that in the uh, integration of kits with Azure DevOps article, where I have explained why this setting of the permissions is essential. So you can also check it out. Now, the next thing that we need to do is, after we have set the permissions, we simply need to run the tests, right? So not Cypress test, but I'm going to run kits test. And the command to run the test is, okay, and this is what is very important to understand. In my previous video, I have explained how the command line interface of the tool works, what is the command line syntax, to execute a test case. So if you haven't seen the previous video, please go and see the previous video, because that is a prerequisite for this execution right now. So I will go back to the tool. I will go to the test set, and this test set is what we want to execute via command line. So I'm going to copy, right click, and I'm going to get the command line syntax from here. And if I go back to the editor, paste, so this is what I need to execute. Now, few things to note. We are going to use an Ubuntu machine or an Ubuntu agent on which this execution is going to happen. So a batch file execution will not work. As I had already explained in my very first video, the batch file is only for Windows. The command file is for Linux or Mac. So I'm going to use run.command. Sorry, typo. The project location is the location of my local machine. It doesn't have to be the absolute location, but can be the relative location. So I can only say projects and then my first project. The slash will be in the other direction. The release name is release 1 and the test set is set 1. This is fine. So this is the most simple command that you can think of, which has all the mandatory parameters to execute this test set on this Ubuntu machine or the Ubuntu server. And once the execution is over, we need to upload the test results, right? So this is a GitHub action that is already there in my previous YAML. But if we want to understand more in details about GitHub actions upload artifact, we can go to the very first link, and it explains us what is it that we need to do to upload one file, and what is it that we need to do to upload an entire directory. So what I will do is simply copy this, and I'm going to paste it here. Okay, I do not need the Okay, now the name of the artifact that I'm going to publish is test results, and the path that I want to publish is so if I go to kits, if I go to projects, um, and my first project, and then if I go to results, test design, this contains all the results of the execution that you would do from the design pane, and this contains all the results of the execution that you do from the execution pane. So we have to enter into test execution. Release 1 is the name of the release, if you remember. Set 1 is the name of the set that we have, and then we need to publish this latest folder. This latest folder will have all the logs, all the in the web service folder. It has the requests and the responses, and all the requests and responses that it would perform are going to be stored here. The extent reports, the summary HTML, the detailed HTML, everything is stored in this latest folder. Okay, so what we essentially need to do is upload this latest folder. That's all that we need to do. Now, if you remember, the location that we need to pass here is a relative location. We do not have to pass the full location. So we will say projects, my project. We're going to reverse the slashes, and under my first project, under the results folder, under test execution, under the release 1 and set 1, and under the latest, we will have the test results. So this is what we need to execute. Um, so the YAML is more or less ready, but we need to enter some more parameters to make this execution work. This execution that we have is composed of um, two API test cases and one UI test case, right? So in Kits, we see we have two API test cases and one UI test case. The API test cases are okay to be executed from this agent, and they are going to run. That's okay. But for the UI test case, it requires the Chrome browser. Now, the Chrome browser is not available in this Ubuntu machine. So, what do we do under these kinds of situations? So, it is okay to configure your tests to run on a remote server called Selenium Grid, or any of the cloud provided services like Sauce Labs, for example. Now, in order to execute your tests uh, in Sauce Labs or Selenium Grid, Kits provides an option to configure the execution to run on Grid. So if you click on the settings icon, you have the execution mode as local. So local will open up the browser on your machine, or at least it will try to open up the browser on your machine. In the Ubuntu machine, it will not find it and it will fail. But in our local, machines, it will find the browser, it will open up Chrome, and the execution will go on. So what we have to do is we can set this as grid as in it will start executing in a remote machine, and we have to pass the remote grid URL. Now here I will pass my Sauce Labs remote grid URL. I have a Sauce Labs account from where I have a specific remote URL which contains my user ID and password, so it's a secret. So I will not be passing it in the tool. I will not be pushing it to GitHub so that it becomes public, but I will do something else. As of now, what I will do is I will bring it back to local. I will leave it as is. I will save and I will close. Okay. Now, let's go back to Kits. Now, there are a few things about the command line syntaxes of Kits that is really amazing. If we go into projects, into the project that we are going to execute, uh, into the settings, there are two types of settings. One is a project level setting. Now, there is a user defined settings dot properties. It's a properties file. And then we have execution level settings. So under the test execution, we have release 1 and we have set 1. There we have two types of properties files, the run settings.properties and the test management settings.properties. Let me actually show you what these are. So in Kits, this is the test set. So we have set 1, right? Under release 1, set 1, we have the run settings.properties. So from the UI, we have the release 1, set 1, and if we click on the settings icon, we have the run settings.properties. So whatever properties that you are seeing on the screen, in the UI of the screen, is actually a properties file behind the scenes. So if I open this up, I will be seeing all the properties that are present on the UI of the screen. Let me open the properties here. Yeah. So the execution timeout, the parallel execution, whatever environment, the grid execution, and everything that you're seeing is actually present in the properties file. What it does is it gives us the flexibility of updating this at runtime on the fly using command line syntax. So, for example, uh, if I set this as local and I do not set my remote grid URL, I save it and I push it to Git. It would mean that if I try to execute my test set, it would force it to run locally. That is, on the Ubuntu agent, it will try to find a Chrome browser which is not there, and the execution would fail. Now, via command line, we can override all these values. Okay, and I will show you how we are going to do that. Another example is we had created a user-defined variable called password. Now this password, I'm going to, as of now, pass it from the tool, but what if this password was a secret password and you would want to store it somewhere in Git as Git secrets, or in Azure DevOps as Azure secrets? So in that case, you would want this password value to be updated at runtime from the command line. So I'm going to do exactly that for this execution. This remote grid URL will be dynamically set from command line in the GitHub Actions YAML. What we will also do is we are going to set this environment also dynamically, because we can create the same YAML by just changing the value UAT or test. We can trigger the execution in either of these environments. So we would also want to keep this flexible. Okay. Now, two things to note for the environment and for the remote grid URL. What is the corresponding properties? For environment, we have test env, and for remote grid URL, we have remote grid URL. So these are the two parameters that we are going to alter from command line, and we would also alter the execution mode. If you see, the execution mode is set to local. Via command line, we are going to force the execution mode to be grid, and then we are going to also pass the remote grid URL. We are going to change this URL to my Sauce Labs URL, which is going to be stored in GitHub secrets. And we are also going to parameterize the test environment. Okay, let me close this. Now, if we go back to the YAML, we are going to create two environment variables. So we're going to say env colon, and we are going to say um, environment to execute, and we'll put a default value as test, right? So the default value is set to test. And then we are also going to use another, define another environment variable, remote grid URL. And that is something that I have not defined yet. Okay, this is supposed to come from GitHub secrets, right? In order to create GitHub secrets, what we have to do is we go to our repository, we go to settings, go to secrets, actions, And here we can create a new repository secret. Execution URL. Now here I'm going to pass my Sauce Labs execution URL or Sauce Labs remote URL. And then simply click on Add Secret. So now a new secret has been created called remote execution URL, which currently holds the value of my Sauce Labs execution URL. So I'm going to copy the name of this secret, and to use it in the YAML, we just need to use the $, open curly braces 2 times, and then say secrets dot, and then the name of the variable, and that's it. Okay, so we have defined 2 variables. One is the environment to execute, and the other one is a remote grid URL. How do we actually use these 2 variables in the execution? All right, so this part of the command line remains the same. Now, all we need to do is we have to say minus set env, okay, and then within double quotes, since these are runtime variables, right, these belong to run settings dot properties, we are going to say, so we are going to first pick up the execution mode. So execution mode, copy, and we're going to say run dot execution mode, yeah, equal to grid. So we are going to override this value local with grid. Okay, so that's one thing done. Now we are going to take this, the same syntax. We're going to paste it after this, and we have already managed the execution mode. Now we want to manage the remote grid URL. Okay, so the remote grid URL run dot remote grid URL. This will come from this environment variable that I have just defined. So copy. The way to do it is dollar and then remote grid URL. As simple as that. And finally, we are going to use the same command minus set env run dot, and we are going to change the test env because we want the environment to also be parameterized, because we can change it from test to UAT depending upon our requirement from the YAML. So run.test.env, and this will also come from the variable that we have just defined. So environment to execute. Dollar environment to execute. That's it. Now our pipeline is ready, as in the code for the pipeline is completely ready. So if we go back to the main location, we have added this .github folder, which has the workflows folder, which has the execution.yaml file. Now, if everything goes well, as soon as I push this to GitHub, the GitHub actions will trigger and the execution will begin. Let us see what exactly it will execute. It is going to execute this test set, which has an API scenario delete, which will fail because we have an injected failure, a wrong assertion. We have a GET request, which will likely pass, and a UI scenario which will be executed remotely on a Sauce Labs browser, and hopefully it will pass as well. So this is what it will execute. Um, let's open up Git Bash. So we're going to say git add space dot. Let's add everything, all the changes that we made. Um, git commit minus m. Maybe we can do a git status before that. Okay, so the changes that we are going to commit are these. So we have some new files that are created, and some of these properties files got updated. Yeah. So I'm going to git commit minus m with a message saying created GitHub Actions YAML, and then we do a git push. All right, now we have pushed it to GitHub, and hopefully the execution will begin. So we click on Actions, and we see that um, the pipeline has been triggered. A new pipeline has been created, and then it has been triggered. And if we step into this, we see that the build is executing currently. It has set up Java 11. The kits uh, test is also being triggered. This is the UI test that is currently being executed on the remote grid server, and the test got completed. Uh, we have the UI test, which has passed successfully. The total test cases that were executed were three. Two test cases that passed were the UI test and the get API test, and the failed one is the delete API test. Now, it has also uploaded the results. So if we go here, we see that the artifact test results has been successfully uploaded. In order to access that, if we click on Actions and step into this one, we should see the build along with the test results which were uploaded, and you can now click on the test results to download the zip. So this is more or less about how we can set up continuous testing using a CICD tool. In this case, I have used GitHub Actions. Hopefully, you find this video informative, because then you can use similar principles for setting up continuous testing with kits for any CI/CD tool that you're using. With this, we come to the end of this video. If you have any questions regarding any of the topics that I have covered, um, please feel free to put down your comments in the comment section. I would be happy to respond to them. If there is any specific item that you would want me to cover, also put that down in the comment section so that I can take it up in one of the further videos. I hope you would like this series. I wish you happy testing and enjoy your time in this new year. Thank you so much.